All right, Algebra 2, this is a humongous unit. You remember way back in the day when we were graphing parabolas and we had different ways to graph parabolas? The first form of a quadratic that we talked about was standard form. That was ax squared plus bx plus c. And when you want to graph that, the first thing you need to do is find the axis of symmetry. That's the opposite of b, and this problem is 4 over 2 times a, negative 1/2. So negative 4 divided by negative 1 is positive 4. Axis of symmetry so far, I got positive 4. I'm going to go ahead and graph that. That's right here. And when you plug 4 in, so if I plug 4 in for x, if you plug 4 in, I can do that on my calculator. I got 1. I plug 4 in, you get 1. That's the vertex. So I know the vertex, and you should know that since this is negative, it's going to open down. We just got to figure out some more points to graph. One easy point from standard form is the y-intercept. If you plug in 0, 0, 0, negative 7, 1, 2, 3, 4, 5, 6, 7, there's that. Then you can reflect that to get 8, negative 7, that's down here. And then I want 5 points, so one other point. If you plug in the point 1, if you plug 1 in for x, you'll get negative 3.5. So I'm just plugging in that, and I get 1, 2, 3, about right there, and I'll reflect that 1 in. And now I've got my quadratic in standard form. Something like that. It's pretty good. This is called intercept form, x minus p and x minus q, and there's an a out front. In this problem, the a is 1, so you don't really need to worry about it. But from this, you can tell where it's going to cross the x-axis. What would you plug in to make this 0? If you plugged in negative 3, that would be one of your x-intercepts, and the other one would be positive 2. So positive 2 is my other x-intercept. If you know the two zeros, now you can figure out the axis of symmetry will be between them, 1, 2, 3, 4, 5. So in the middle of, these two are 5 apart, in the middle that would be 2.5. So like right there, that would be negative 0.5. That's the x-coordinate of the vertex. And when you plug that in, negative 0.5 for x here, negative 0.5 for x here, when you plug that in, you should get negative 6.25. So these are kind of gross. Negative 6, 1, 2, 3, 4, 5, 6.25 is down here. And then you got to pick one other point. The other point that I picked was I went ahead, and plugged in a 1. So if you plug in 1, 4 times negative 1, you're going to get negative 4. 1, negative 4. That's negative 5, I think. Let's see. 1, 2, 3, 4, and then I could reflect that 1 inside here, and now I've got my quadratic in intercept form. So try to sketch that. Strike. There we go. The last graph that you need is in vertex form. Remember, that's a times x minus 8 squared plus k. And in this problem, that means they plugged in a negative 6 and a positive 8 for hk. Negative 6, 8 is right here. And in this problem, you're going to go off the grid pretty quick. Usually we would graph the y-intercept, but in this problem, the only other one I'm going to be able to find is right here. That'll tell you the axis of symmetry when you have the vertex. So the last point, I'm only going to have one other point. If I plug in negative 5, you get 1 squared, 2 times 1 is 2, add 8, you get 10, so negative 5 is here at 10, and then for this problem, I'm only going to be able to fit 3 on this grid, so something like that. And that is all the ways that we have graphed a quadratic.